How is a through-thickness conductive network formed within a homogeneous ESD sheet? A conductive ingredient cannot span an entire flooring sheet by itself. The engineering question is how separate elements become connected paths through the material body. Judy Matrix Notes 003 follows the answer through 6 structural levels. These are not 6 physical flooring layers. The product remains a homogeneous sheet, meaning the wear-bearing body has the same material construction through its thickness. The 6 levels are a way to examine how the intended conductive mechanism develops from local elements to material-wide continuity. The first level is the functional element within the metal-oxide conductive phase. It is compounded into the PVC matrix rather than applied as a temporary surface treatment. No single element carries charge across the whole sheet. Its role is to become one potential link in a larger architecture. The second level is distribution. The metal-oxide conductive phase is intended to be distributed throughout the PVC matrix and the full thickness of the sheet. That spatial reach creates opportunities for neighboring conductive elements to form electrically effective links. Distribution is necessary, but distribution alone does not prove that a connected network has formed. The third level is a connected population. The presence of a conductive phase is not sufficient by itself. Loading, dispersion, spacing, agglomeration, and preservation during processing all influence whether enough local links can form. Elements that remain too isolated cannot create a material-wide pathway. Elements concentrated into poorly distributed clusters may also leave gaps elsewhere. This is why an ingredient name alone cannot predict finished electrical behavior. The fourth level is network formation. When local links become sufficiently connected, multiple routes can extend along the sheet's length, width, and thickness. Together, those routes form the intended three-dimensional or percolating network. Electrical continuity, therefore, does not depend on one single element or one isolated surface point. The word intended matters here. Architecture explains the design mechanism, while testing evaluates the electrical outcome. The fifth level is consolidation into the material body. Heat and pressure consolidate the compounded PVC around the distributed conductive phase. The result is intended to be a dense, compact, homogeneous PVC body. The conductive function is not confined to a separate conductive surface layer. The wear-bearing body itself contains the conductive phase. The sixth level is continuity across wear planes. As normal wear lowers the working surface, each newly exposed plane is intended to continue containing the metal-oxide conductive phase. That is the structural basis for through-thickness continuity. It does not mean resistance can never change. It means the conductive basis is not limited to the original surface or removed as one surface layer. Current product testing and installed system verification still remain necessary. A through-thickness network within one sheet is only part of the installed flooring system. Where adjacent sheets meet, compatible conductive welding rods support electrical continuity across the seam. The welded seam does not ground the floor by itself. Conductive adhesive, copper foil, an approved ground connection, and installation quality remain part of the completed pathway. The installed system must be verified rather than inferred from the sheet architecture alone. The central lesson is that structure determines function. A conductive ingredient is not automatically a conductive phase. A conductive phase is not automatically a material-wide network. A network inside a finished sheet is not automatically a verified pathway to ground after installation. Each step must be understood at the correct level of evidence. The internal network described here is the design mechanism stated in the available manufacturer materials. The reviewed electrical reports confirm the behavior of submitted samples under the stated methods and conditions. They do not directly confirm the exact microscopic distribution or connectivity of the conductive phase. That would require representative microstructural characterization capable of resolving the relevant internal structure. Finished product testing evaluates electrical outcome. After installation, the complete pathway to ground must still be verified. The answer is not one magic ingredient. It is a chain of conditions that connects local conductive elements to a consolidated material body, and then to a verified installed system. Read the complete Judy Matrix Notes 003 at judymatrix.com. Next, if two ESD floors claim the same resistance range, are they really comparable? See beyond.